Alright, this is lesson 53 for Algebra 1, identifying spread and shape of distribution. So what we're talking about today is we get data from everything, remember, and data is useless unless we make meaning from it. So one way we do that is we make histograms, or something that looks like histograms, which shows a distribution. Remember histograms? We have those bar graphs, remember that? Okay. So we're kind of looking at something called distribution chart or distribution curve, which is just like a histogram, except it's more specific, okay? And a distribution, you look down here, it says it's the way data looks like in a population, okay? So data could look different ways. So I'm going to teach you what the different forms of data look like, and then tomorrow we're going to be looking at how to make this. We're going to do like a little mini task together. All right, so these are the different types of distributions. So the first thing we're going to be looking at is spread. If you look at the top where it says spread, there's two ways that it could look like. It could be less spread where all the data is together, right? So raise your hand if you are 13. Wait, how old's the youngest? 13-year-olds. Are there any 13-year-olds in here? Are there any 14-year-olds? Are there any 15-year-olds? 16-year-olds? 17-year-olds? 18-year-olds? So most students are 14 through 16 in here, right? Are there any 18-year-olds, 19-year-olds in here? Okay, what is the minimum age of a person? No, minimum age of a person possible. What's the minimum age? When you're born, you are?
1 second.
0, right? What's the maximum age? The oldest person, I think, is, let's just say 100. Okay, it's over 100, of course. Right? But most people are in here are 14 through 16. Is that a widespread of the total possible lifespan of people? No, it's a very little spread. It's less spread, right? Okay, or more spread could be, let's make another thing. Let's say I took the whole population of San Dimas and asked each person how old are they? Well, they would be spread across the whole thing from 0 all the way to 100, right? And we would see a curve of people, right? This is, by the way, a distribution curve. You could see that. All right, so that's the first thing is spread. The second thing we're going to be looking at is the shape. There are different shapes. Okay, symmetric. You know how your face is symmetric? If we drew a line down your face, you should have an eyeball on each side of that line, right? And a nostril, right? And your teeth look pretty symmetrical, right? So that's the same with this. On this first one, you could have a curve that's very symmetrical, which is kind of perfect, like it looks like a perfect curve. And it's unimodal, which means there's only one set of data. If you look right underneath it, you could have two symmetrical curves, but there's two of them, so it's bimodal, which means there's two sets of data. Okay? Or it might not be symmetrical. It might be non-symmetrical bimodal, which you might have a tall curve at one section and then a little curve in another section, right? Non-symmetrical bimodal. Or everyone could have the same thing, right? How many total lives do you have on this earth?
1.
Raise your hand if you have 1 total life on this earth. Raise your hand if you have 2 total lives on this earth. So everyone has how many total lives on this earth? 1, right? So I could ask there could only be 1 total life on this earth if I asked everyone. Okay, another one is skewed right. Now this looks kind of funny because it says skewed right and everything is toward the left, right? Do you see how it grows on the left? But this means skewed right. We call this skewed right. And this could be an example like how many total bibs you have. Raise your hand if you have 0 bibs. Most people have 0 bibs. Raise your hand if you have 1 bib. Well, there's a lot of people that just might have 1 bib in their whole time. And then there's more people that have 2 or 3 or 4 bibs. And there might be like 1 or 2 people that have 5 or more bibs in this class. Does that make sense? But most people have 0 bibs or detentions, right? Or we could have skewed left, which is the opposite. How many hours of sleep did you get last night? Well, most kids had 10. Some kids had 9. Still, a lot of kids had 9. A lot of kids had 8. And there's less kids at 7, 6, 5. And there's even a kid that had 4 hours of sleep. But no one had 3 hours or less. Does that make sense? So that's an example. Are you following me so far? This is a distribution curve. So you could see that the line is kind of looking like this, or it's looking like this. All right? So we have uniform. Then there's this thing called a gap. Sometimes you have two different, or you might have emphasis points in two different areas, okay? This could be like, how many pictures do you take in a day, okay? If I asked you, there could be kids that take one picture. There's a few kids that take two pictures and a few kids that take three pictures. Okay? That's where most kids take pictures, right? And then there's a whole other group of people that take a lot of pictures. They might take 8, 9, or 10 pictures. Okay? Which is, very similar. It's symmetrical, but there's a gap in the middle. There's no one that takes 4, 5, 6, or 7 pictures. All right? And then last but not least, let's just say this last one. Let's say snacks a day, okay? Okay, you have your meals, okay? But then you have snacks, right? Snacks are between meals. You might have like a bag of chips, or you might have like a candy bar, or you might have an apple, or I don't know. Okay? Most kids have either 1, 2, or 3 snacks a day, right? Most kids have 2 snacks, and a lot of kids have 1 or 3 snacks, okay? But no one really has 4, 5, 6, 7, 8, or 9 snacks, okay? But in my population, when I took a survey, there was one kid that has how many snacks a day? 10 snacks. They just snack all day. They have breakfast and then they just start eating. They just start eating donuts and snacks, okay? Right? This is called an outlier. This is someone who is not normal in the population. Doesn't mean that they're unnormal normally, but it just means it's unnormal, okay? Right? All right. So those are the different models. So you have to memorize all of this stuff up here, and then you're going to look at a picture and tell me what it is, okay? You just say what it is. That's the goal for today. It's identifying, okay? Because in statistics or in real life, when you look at a graph, you need to think oh, is this graph make sense? What is it doing, okay? And if you are take statistics here in high school, you take AP Stats, it's actually a really fun class. Mr. Kim teaches it super good. He's really good at it. So I would suggest you take that if you're a senior. Super fun. Hi. I don't think this is. I think it's O3. Try O3. Brandon? Yeah, no. Try O3. Okay. So let's do number 1 and 2. Watch up here. Let's say I ask kids, how much cash do you have in your pockets, okay? And there's kids that have $2. There's kids that have $3 and $4. That's it, okay? Let's just say I asked all of you. This is what my curve looks like. What does it look like? Well, I'm going to first ask myself, what's the spread? Is it more spread or less spread? Well, this is less spread, right? Kids really only have $2, $3, or $4. They don't really have anything else, right? And then I ask myself, is it symmetrical? Does this look symmetrical? Yeah. And then how many modes are there? Well, it's only one mode, so we say it's unimodal. Symmetric, unimodal. And that's it, okay? That's all we're doing today. Okay, so what did I do? I asked myself, what's the spread and what's the shape? Okay, was that hard? No, it wasn't hard. Okay, I'm not asking myself, why do kids have this much money? Why? But let's ask ourselves anyways. Why do you think kids only might have $2, $3, or $4 in their pocket?
They don't have jobs.
They don't have jobs. So does that mean they have a lot of money? No. Okay. And what do they do with the money they have already? They spend it, right? So they might get like a $5 allowance from their parents every day, or they might say, go buy lunch. And what do you think they do? They probably get to school and they buy a snack. And then what happens? They might have a few dollars left over for lunch, or they might spend it all, right? Okay, number 2. Let's say these are shoe sizes on a football team. Let's say I asked all the kids on the San Dimas football team. Okay. So these are all the sizes. Okay, what do you notice about this? Okay. Well, looking at this, is it unimodal or bimodal? Well, I think it's unimodal because there's only one big area of the population that's like this, right? So I would say this is unimodal. And I would also say, is it spread? Oh, I'm sorry, we forgot to do spread first. Is it a wide spread or is it a less spread? Wide spread, good. And next question, do you notice any other features? Is it symmetrical? No, it's non-symmetrical. So we're not noticing any symmetry here. Next question, are there any other unusual features? Well, looking here, what do you notice here? Are there any people with size 4? We call that? That's a gap, okay? So we'll call this a gap. Okay? And then what do you notice about 16?
Outlier.
It's called an outlier. If someone has a size 16 shoe, is that normal? No. So we'll call that person an outlier, or his shoe size an outlier. Okay? So this one has a lot more data to think about, right? Okay? That's all we're doing. Any questions on numbers 1 or 2? No. Okay, so why don't you turn to your neighbor, explain 1s tell the 2s about how we explained or how we figured out the first spread and what the shape, and then 2s tell the 1s how we figured out all the different parts. 2 examples down. I want to show you something. I want to be a little more specific on number 2. Look at the curve I made. I'm going to erase the curve I made. But my curve really looks like this. If I think about it, it goes up really quick and then it comes down slowly, right? And then kind of, you see that? So it kind of goes up more quickly here and then it goes down slowly, right? Okay, continuing on number 3. Okay, turn your neighbor, tell them what kinds of things are you noticing on this one. What kind of spread first? More spread or less spread? This is the number of digital books on your device. More spread or less spread, everyone? Less spread, right? It's not like there's a lot of people with a lot of different values. There's less spread. There's only like a couple of pockets here. Okay, now turn to your neighbor. Tell them, is it symmetrical or non-symmetrical? I would say this is non-symmetrical. This first one is skewed left or right? Skewed right, good. What other things are you noticing? There's a gap, right? So we notice there's a gap right here. And then what about this right side? Look at this distribution here. Is it symmetrical or non-symmetrical? Symmetrical. Okay, good. Now I want to ask you something. Is this unimodal or bimodal? Unimodal, right? Uno? Are there two sections of data or one section of data? Two. So is it bi, like a bicycle with 2 wheels, or unimodal, like a unicycle with 1 wheel? Bimodal or unimodal? What do you think? It's bimodal. Okay. I knew you liked bikes, so
thank you.
I made that. That one's out to you. Okay.
I ride unicycles.
I do too.
Very easy.
Is it?
Yeah.
Okay. You remind me of me. You will be a math teacher one day, like me. Okay. Here we go. Let's do number 4. Let's have you do this one by yourself. Okay, show me what the answer is. Let's see, these are the ages of students. I counted every 14-year-old, 15-year-old, 16-year-old, 17-year-old, and 18-year-old at San Dimas High School. And this is the data I got. What can you tell me about this? Ready? Go. So this is less. It could be more or less spread depending how you compare it. I'm going to just put, for this example, it looks like I think it's less spread. Okay, because I would have expected more kids to be 14 and some to be 19. And this is, of course, uniform. Every age is the same. Okay. Continuing on, number 5, okay? Let's say I asked all the kids, how many pencils do you have in your bag? One kid says 0. One kid says 2, one kid says 3, one kid says 4, 2 kids said 5, 4 kids said 6, 5 kids said 7, 8 kids, or 8 kids said, or I'm sorry, 5 kids said 7 and 5 kids said 8. Tell me, what's the spread? And describe the shapes to me. Okay, on this example, we're noticing there's an outlier here, okay? So that's one thing you should have noticed. And we noticed that the spread is pretty wide. It's pretty much all the way across. The only one that there isn't one, there's a gap here at 1, right? Okay, so it's a wide spread. And we notice that it's skewed left or right? Skewed left. Good. Okay. This is really all you really need on this one. We know that it's not symmetrical because it's skewed left, so we're assuming that when we say skewed left. Okay. Last one. Number of pairs of shoes owned. Okay. Let's say I asked every student here. One student says he has 1. Two students say they have 2 pairs. One student says they have 3. One student says they have 7. 3 students say they have 8 pairs. 4 students say they have 9 pairs. And 1 student says they have 10 pairs of shoes. Okay, what do you notice about this data? Go. He's funny. He's a good guy. He comes in here sometimes. And so, on this one we're noticing that there's a symmetrical bell shape here, and then we have a non-symmetrical shape here. So we have, it's bimodal. I think it's less spread, right? It's not really across the whole spectrum of possibilities. And it's bimodal. That's right, there is a gap. Okay, what else do you notice? Anything else? I think that's it, right? And I would say it's non-symmetrical, at least the first bell-shaped curve is symmetrical, but the second one is not, so you would have to be able to see that, okay? And that's it. So that concludes this lesson. So please...